Hey, this is Coach Latham, your SOL coach, getting you ready for the Algebra 1 SOL, and today we're going to talk about slope in under 15 minutes. As a side note, you could use this video in geometry as well. Slope is a major topic in both of those courses. I want to take a look at these lines that I have on the board right now. It doesn't matter where they are, they can be positioned anywhere on the board, but the identifying factor of all of these lines on the board is how inclined they are. Some of them are going up when you read from left to right. This one's going up. This one is going up. Some of them are going down when you read from left to right. This one's going down. This one right here is going down just a little bit. And then some of them don't really go up or down. This one right here is perfectly flat. And we could call that horizontal, just like the horizon. And this one right here is going straight up and down, and we could call that vertical. So what happens is we know something about the slopes of these lines. Lines that go up from left to right are going to have a positive slope. This one right here is positive, as well as this one, positive slope. If the line is going down from left to right, this one's going to be negative. This one's going to be negative. The one that's going neither up nor down has a slope of 0. M is the symbol for slope. Got a slope of 0. And the one that is going straight up and down, vertical, is said to have a slope that is undefined. We'll come back and check and make sure you memorize those later on. But the easy way that I have of remembering it is if you had a skier on this slope, kind of a strange looking skier, and he was skiing down this slope, he would hit the ground in a horrible mess. He would be undefined. So that's just my trick for remembering them. We've got another example here I just want to show you to talk more about slope. Let's hope my technology works here. We've got this line right here. It starts out being undefined because the slope is too big to measure. But as we start swinging it around, we've got a very positive slope. We're like going up 3 over 1. We're going up 3 over 2. These are big slopes. And then we finally get over here to where we're going up 1 over 1, up 1 over 1, up 1 over 1. You can see the little staircase working up here. Up 1 over 1, up 1 over 1, up 1 over 1. So this line has a slope of positive 1. The slope keeps getting more negative, or it gets less positive, I should say. We've got positive fractions, then we get down here to where it's 0. Then we got little baby negative slopes, like maybe down 1 over 4, so it'd be a negative 1/4. We work our way all the way down to negative 1. And then as we get bigger negative, we finally get to where it's undefined again. So that's kind of like another way to think about slope. This is what some of the problems look like on your SOL test. These are the problems that we really like because they're easy. If we're going to go from here to here, remember we always go from left to right. The way that we measure slope is by going up, rise, up 1, up 2, up 3. Overrun, over 1, over 2, over 3, over 4. It's rise over run. So the slope for this line would be 3/4 because we went up 3 and over 4 to get to another point on the line. Usually on the SOL test, they tell you, or they give you graphs that cross the x-axis and the y-axis. Here's the x-axis and the y-axis right on a grid marking, so it makes it easy to count up and over. Let's take a look at another one. And you can hit pause on this if you want to before I show you the answer and try and figure out the slope. If we're going to find the slope on this looks like a pretty good dot to start with right here. This one looks pretty good right here. To go from left to right, we're going to go down 1, down 2, down 3, down 4. So I'm going to put a negative 4 right there, and we're going to go over 1, 2, 3, 4, 5. So it's down 4 over 5. So this one is going to have a slope of negative 4/5. And that makes sense that it's negative because we talked about that on the other picture that it's going down when you read from left to right. Take a look at another one. We won't waste a whole lot of time on this. I think we should have it by now, but this looks like a pretty good dot. This looks like a pretty good dot. We go up 1, 2, 3, 4, and we go over 1, 2. We go up 4 over 2, so our slope is going to be 4 over 2. And when we have a fraction that'll reduce, we just reduce it, and this is going to reduce to 2. It's a slope of 2. That means that for every 2 you go up, you go over 1, so you can kind of break this one down if you wanted to. You go up 2 over 1, up 2 over 1, and see it does the same thing as going up 4 over 2. All right, these two lines are parallel, and parallel lines have the same slope. I think everybody has a pretty good concept of what parallel means. They look like train tracks. If we were going to look at these two, this one goes from here to here. I'll go ahead and pick a couple of dots that correspond with that. This one goes down 1, 2, 3, and over 1, down 3 and over 1. So that line has a slope of -3 over 1, which is -3. And of course, we're going to get the same thing here, down 1, 2, 3 over 1. So this slope is also -3. Parallel lines have the same slope. Here we've got, oh, I told you there'd be a test later. Go ahead and hit pause just for a moment and see if you can match these 4 slopes over here with the 4 different colored lines. So go ahead and hit pause. Okay, we're back. Hopefully you matched them all up correctly. Let's see, the yellow line we'll start with, it's going up from left to right. So the yellow line has a slope that's positive. The green line, we'll look at that one up on the top. It's perfectly flat. It has a slope of 0. The blue line is going down from left to right, so that has a slope that's negative. And that means that the undefined slope is this red line over here. Remember, if the skier is going down the red line, he's got issues at the bottom. All right, let's take a look at one more. We're going to count off the slope the way we already know it. We're going to go from this point to this point. And in order to get from there to the other, we go up 1, 2, and we go over 1. So we go up 2 over 1. So we know the slope of this line is 2 over 1, or 2. Now what I want to do is take a look at the coordinates of these points. This point right here, in particular, has the coordinates of 0, 3. This point right here has the coordinates of 1, 5. If we said 5 minus 3, we get 2. That's the number on the top. And if we said 1 minus 0, we get 1. That's the number on the bottom. So another way of thinking of rise over run is change in y over change in x. And that brings us to the slope formula. The slope formula can be thought of as how far up or down you go, rise, over how far over you go, run. We can also think of it as change in y because the y coordinates tell you how high you are over the change in x. And then a lot of people like to write it out the long way, y1 minus y2 over x1 minus x2. Some people say y2 minus y1. It all means the same thing. It's the difference in how high you're going up divided by the difference in how far you're going over. So let's take a look at this. Now, we don't have a picture here, but we have the coordinates of 2 points that are on the line, and we want to find the slope of this line. Remember, it's rise over run, so the y coordinates are going to go on the top. The y coordinate from the first point is 4. The y coordinate from the second point is -3. They go on top. The x coordinate from the first point is 5. And the x coordinate from the second point is 3, so those numbers go on the bottom. So this is how we figure out the slope when we're given 2 points. Now we have a bit of arithmetic. We've got 4 minus -3, which is really 4 plus 3, which gets you to 7. And we've got 5 minus 3, which is 2. So the slope of this line, the line that contains those 2 points, would be 7 over 2. If we were to graph it, you would go up 7 over 2 to move along the line. The next one we're going to look at, we're going to do the same way. We've got 2 more points and we want to find the slope of this line. Remember, the y's go on the top. The x's go on the bottom. And then you've got your arithmetic to figure this one out. We've got -5 minus 2, which is going to give you -7. We've got 5 minus 3, which is going to give you 2. So this one has a negative slope, a slope of -7/2. Got one more that I want to look at. This one's kind of a special case. First thing we're going to do is put our y's and our x's where they go. So the y's are going to go on top. The x's are going to go on the bottom. And we do that math. And -2 minus -2 is the same as -2 plus 2, which is going to give us 0. 7 minus 3 is 4, and 0 divided by 4 is 0. So we automatically know that this line is going to be a flat line because it has a slope of 0. If you just wanted to kind of sketch it out in your head, you could go over 1, 2, 3, 4, 5, 6, 7. And then we only need to go down to the first point right here. 7 -2 is going to be over 7 down 2, right there. This second number, 3 -2, is going to be over 3 down 2. And you can see that when you connect these dots, if my picture drawing is okay, we're going to get a horizontal line with the slope of 0. Now, that's everything you need to know about slope. The next step will be to move into writing linear equations. Hope this has helped you. Have a great day.